All right, we are going to talk about 8.4, which is discussing correlation coefficients. We'll go over some quick vocabulary words first, and then we will look at some examples in Desmos. All right, so the first thing is a correlation coefficient is a number between -1 and +1. So that's a really important thing to know. And it describes how good of a data set is to our line of best fit. So we're comparing it to our line of best fit. Now, if we get a really terrible number out of this, sometimes it tells us there's no correlation. Sometimes it tells us we need to try a different model. Maybe our best fit should be something like a quadratic function, or maybe it needs to be a different type of function other than a linear one. All we're going to do is tell if it's a good linear fit or it's not a good linear fit. So if the number is positive, we're going to have a positive correlation. So just like this picture over here on the left, we have our bunch of scatter plot values, the red line of best fit. The data is pretty close to the line itself. It's not on the line, but it's really close to the line. If the number is negative, we're going to have a negative correlation. So just like this picture over here on the right side, the slope is negative. Again, the values are very close to the line itself. The closer it is to 1 or -1, the better the data is. So I would say both the pictures and the positive correlation and negative correlation are pretty good. They're going to be close to 1 or -1. If it's close to 0, we're going to get a picture in the middle like the no correlation graph. And again, it could be maybe something spread out like this one, or it could just be a different shape as well. All right, we're going to head over to Desmos, and now we're going to look at some data values. So on this is just kind of a random set of data. We've got them plot in Desmos. You can use a table to plot any sort of data values. The nice thing is you can copy and paste a table from like Excel or Google Sheets, and you can paste them right into Desmos and it'll graph it for you. All right, so first thing is notice that in our table, our X values are called X1, our Y values are called Y1. We're going to use that to find our correlation coefficient as well as the equation of our line of best fit. So we're going to type in our keyboard y. Basically, again, it's y equals mx plus b, but specifically we're using y1. So just type in y1, the 1 will become smaller automatically. Then we want to use the squiggle. It's the button. You have to press shift right next to the 1 key. And then mx, and then again, it's x1 plus b. So again, it looks like y equals mx plus b here. Okay, so a couple things that you might have noticed. I'm going to change this to a green line so it matches our data. Down at the bottom, you'll see M and B. That is your slope is your M, and your B is your y-intercept. And that should match. So our slope is a positive value. It's about 0.9 if we want to round up. And our B value is negative 0.7, which is right there on our graph. So this is how you can write the equation of your line of best fit. You won't have to be able to do this by hand, just be able to use the tools in Desmos to be able to write your equation. So your M and your B are there. The other value you'll have to pay attention to is the R. Ignore the R squared, ignore everything else. All you just have to know is R. R is your correlation coefficient. So this one, we have a positive slope. So that means our R value should be positive. And it's very, very close to 1. 0.9, about 0.94 if we want to round that up a little bit. That's a really, really good correlation coefficient. It's very close to 1. All right, let's look at another set of data. Let's go down to our second set. We have this one color purple. If you notice, this is going downwards. It's got a negative slope. So our correlation coefficient should be negative. It looks pretty linear. There's a few numbers, like there's this one over here and this one over here that kind of don't look super linear, but that's okay. Let's go ahead and check it out. Now, I've already typed this in. Notice I use y2 and x2 instead of y1 and x1 because, again, look at our table. It says x2 and y2. So this is how to deal with if you've got multiple sets of data at once in Desmos. Again, here's your M and your B. We've got a negative slope. That should mean our R should also be negative here. So negative 0.94. Very similar coefficient than we had before. It's just it's negative. All right, let's go ahead and look at the next data set. X3 and Y3, we have it in red. Now, already looking at this, it's definitely negative. The slope is going down. Our data is much more spread out. So our correlation coefficient shouldn't be quite as good as the last one. So let's go ahead and check it out. Here's our line of best fit. Again, your M and your B value. Our correlation coefficient is negative. It's about 0.78. Not bad, not great. It's pretty good. There are some points that are on the line of best fit, but there's some that are definitely further away. Let's look at the next set, X4 and Y4. Now this one is very much more spread out. We've got some kind of points all over the place. These top three kind of make it not so it could be negative, but then these top three kind of make it negative or make it positive. So let's go ahead and check it out. This one has 0.06998. That is very close to zero. So this is probably the worst correlation coefficient we're seeing here. This is not really a linear set. You might almost see it's almost like a U shape. So maybe if you were a statistician, you'd look more at, well, maybe we'll get a quadratic regression line or an equation here. That might be a better set, but this is definitely not linear. And let's look at the next set, X5 and Y5. If you notice, this one is everything is on the line here. And take a look at our correlation coefficient is R equals 1. So that means it's perfectly, every single point is on the line of best fit. And our final set of data here, Y6 and X6. This one also looks very linear. It's also negative. So this one is probably going to be close to -1, in which it does equal -1 right here. All right, so at this point, you should be able to know how to use Desmos to find your correlation coefficient as well as the line of best fit. And then hopefully you can also estimate values of our correlation coefficient.